The 12th group elements: zinc, cadmium, and mercury. All of them have electron configuration with full d10 shell. All d electrons occupy all orbitals. Same story with s. 4s2, 5s2, and 6s2 subshells are completed. With Mercury, we also have completed 4f subshell. That's why the only electrons that actually are valence electrons are s. D plays some limited role, but not too much. We can remove both of these electrons, and that's all we can do. So oxidation numbers for zinc, cadmium, and mercury are +2. In addition, mercury makes metal-metal bond, so formally the compound has oxidation number +1. But this doesn't change the whole story. All of these are metals with electronegativity going higher from zinc to mercury, opposite direction than it's usual. Atomic radius, as usual, increases from zinc to mercury. Zinc is metal with relatively low melting point. Cadmium has slightly lower melting point, but mercury is liquid, makes it very special, practically the only stable metal that is liquid at ambient temperature. Zinc is usually found in form of zinc sulfide ores, and this is how it is processed. Metal zinc easily reacts with acid to make zinc 2+ hydrated ions in water and hydrogen gas. It also reacts with oxygen or with halogens to make zinc 2+ compounds. When we roast zinc sulfide on oxygen, we are getting zinc oxide and SO2 gas. Zinc oxide easily reduces bicarbon to make zinc metal that has a relatively low melting point, so it just melts out. Zinc sulfide itself, when it's high purity, is completely transparent, and it's used for instrumentation optical windows suitable for visible infrared area. Zinc oxide is colorless or white. Most of zinc salts, if an ion is not colored, are colorless. Again, the color of zinc sulfide ore is coming from the impurities. Zinc 2+ ion precipitates with hydroxide to make zinc hydroxide. However, it is amphoteric. It reacts with additional hydroxide to make tetrahydroxozincate ion. This is very similar to aluminum. What is different from aluminum is that zinc hydroxide reacts with ammonia to make tetraamine zinc cation, complex cation, which aluminum cannot do. A couple more reactions. Zinc reacts with oxygen to make oxide. Zinc carbonate, similar to group 2 carbonates, make zinc oxide and CO2. We see some analogy with group 2 elements. Oxidation number is 2+ only, and carbonate can be decomposed. Other than that, properties are very different. Cadmium makes same hydroxide as zinc, and it is colorless. It reacts with sulfide to make cadmium sulfide, which is yellow. Very characteristic bright yellow color. Cadmium oxide be made as red, and selenide is deep red. Based on these, there are several interesting compounds that have special use. Cadmium selenide nanoparticles exhibit very beautiful colored fluorescence. Mercury is very dense and very special because it's liquid. Here it's a British coin floating on the surface of liquid mercury. Liquid mercury can be found in nature, but mostly it's obtained by decomposition of mercury oxide, which makes liquid mercury and oxygen, or mercury sulfide oxidation with oxygen, making SO2 and liquid mercury. Liquid mercury is relatively volatile, so it can be distilled for purification. Mercury oxide is orange-red or yellowish. Mercury sulfide is bright red. When it's precipitated from water, it's black. Mercury chloride, well soluble in water, however, it's a complex molecular compound with chloride are directly attached to mercury ions, and it doesn't dissociate. However, it's well soluble in water. It can be reduced with tin chloride to make Ag2Cl2. Here, oxidation number is formally 1, but there is mercury-mercury bond that makes this compound. It is insoluble in water. It can be further reduced by additional tin chloride to make mercury liquid, which will be black precipitate in your beaker. Zinc, cadmium, and mercury sulfides, selenides, and tellurides are very interesting semiconductors, so-called MXOs. So the band gap can be very different and adjusted by changing composition of these compounds. These semiconductors have multiple industrial uses. Mercury, of course, it's famous by its high toxicity to humans. It is coming mostly from industrial activity. However, there is lots of environmental mercury around. And as it's visible from glacier analysis, historical volcano eruptions, Tambora, Krakatoa, St. Helens, which is close to Wyoming, gives lots of mercury in atmosphere. However, industrialization and gold rush, the fact that mercury dissolves gold and was used for gold purification, resulted in lots of environmental contamination. The problem with mercury contamination in fish is fantastically important for fishing industry.